Hello guys, welcome back to the new session of video. Here we are going to discuss about the non-homogeneous differential equation. So first of all, we'll see the standard form of this. So it is d squared y by dx square plus p into dy by dx plus qy, where p and q are the constants, and it is equal to r. R is nothing but a function of x, where in case of homogeneous differential equation we didn't have any r function, where in there we had 0 over there in the RHS side, but here we have a r function which is a function of x. And for the solution of this is quite different from the homogeneous differential equation, where we had only yc over there, complementary function, but here the solution is y is equal to complementary function plus the particular function, that is yp. So here we need to, this yp is with respect to the RHS and yc is with respect to the LHS. Okay, now here we have our different cases, so we'll be solving different problems based on the cases of r. Suppose r is first case, r is equal to k into e power ax. We have different steps to follow in order to get yp. Yc, the steps will remain the same as we have done previously based on a homogeneous differential equation. Now here r is equal to, second case, k cos ax, or we can say k sin ax. K is nothing but the constant. Okay, and third case, r is equal to the polynomial. It can be polynomial also. The fourth case, r is equal to e power ax into v, where v is the function of x again. Okay, so this is a product of two combinations. So we'll discuss one by one and we'll solve problems based on this. So in this video we are going to take up with the first case, that is r is equal to k into e power ax, and discuss the steps followed by that. So first case, here we have e power ax on the RHS side. So this is the first case where r is equal to k into e power ax. Now here left hand side you can see it is same as homogeneous differential equation. The steps will remain the same. First you have to do it in what, d form. That means d is equal to what, d by dx. You have to replace y double dash means d square, then y dash is d, then y we can just take it outside so that you can write it in this form, and which is equal to this RHS we are not going to do first. We are going to do the LHS part, solve this and find the roots first. Now oscillatory equation you can write, since this is in d form, so d you have to replace with m and ignore this y. So after writing this in equation form, then you have to find the roots of this. You can use a calculator or splitting the middle term also in order to find the roots. So there are equal roots 3, 3. That means the complementary function, that is yc, is equal to c1 plus c2x into e power 3x. This is the solution for the LHS side. Now we have to go for the RHS side. Now for the RHS you have to remember one thing. You have to find yp. Yp, always remember that will be in the form k into 1 by function of d into e power ax for this case. Okay, so here we can see 1 by function of d. What is function of the, this part, this whole part you have to write it over here in the denominator, into e power ax. Now the thing is that here different types of e power ax is there, separate terms are there. Here you can see one constant term is there. 5 you can write it in e power ax form, that means e power 0x. You can see over here, that we'll discuss. Now we can just split it in a different way. That means you can take 6 k, this is k, into 1 by function of d into e power ax. This form we are writing, plus you have to take this part also. Again the same thing you have to do. So again you have to do, see this thing, e power minus 2x. So k here it is 1, so we can write 1 by the f of d, that is function of d into e power ax, plus 5. Here you can see 5 I can write it as e power 0x. Anyways it doesn't matter, because e power 0x it is 1, so I can write it in this form also. So k into 1 by f of d, function of d into e power ax. That's it. Now the question comes here, next step. What is the next step? Always remember, for this case k into e power ax, what we need to do is that you have to substitute the a value in d. Remember, a value in d you have to substitute and see whether the denominator is becoming 0 or not. That you have to see. I'll repeat, a value you have to substitute in d and you have to check whether the denominator is becoming 0 or not. If it is becoming 0, then it is not defined, then you have to differentiate. I mean, if it is becoming 0 after substituting, suppose here 3 I am substituting, that becomes 3 square minus 6 into 3 plus 9. I'll get it as 0. So therefore it is not defined. Therefore we need to differentiate this part. Take this d as what? X. Okay, assume it as x and differentiate. First differentiation, remember, first differentiation you have to multiply the numerator with x. So this becomes, denominator becomes 2d minus 6d. Okay, take it as x. You can simply differentiate it. So always remember, first differentiation you have to multiply the numerator with x. Now the thing is that again we have to substitute and see for the first differentiation. See here, d value is the a value you have to substitute here on in d. So 2 into 3 minus 6, that is 6 minus 6. Again it is becoming 0, hence we have to differentiate again. You have to differentiate till you get to some constant value other than 0. Okay, now x square. Why x square? Because we are going for the second differentiation of this denominator. You have to multiply with x square. Remember this. Now while multiplying with x square, denominator, what is denominator? 2d minus 6, differentiation will be what? 2. This is constant 0, so 2. Okay, so this is the constant value, so no need to substitute because here we can see d is not there, so no need to substitute. So here it ends. Now for the case, so this is the part of this equation. Okay, now going for this equation, you can see over here again the same step. You have to substitute the value of a. Here a minus 2 is a, you have to substitute in d. Okay, d value you have to substitute minus 2. So when you substitute the value of minus 2, so here we can see I am substituting minus 2, here I am substituting d is 3. Okay, now minus 2 when I substitute, here you can see this becomes 25. It is not 0, so no need to differentiate this part. Remember, whenever it is becoming other than values, some constant value other than 0, then no need to differentiate. So hence this will be the solution, not solution, this part of solution. Okay, plus now here you can see 5 into 1 by f of t e power 0x. 0 is a, so that means you have to substitute in place of d is 0. So when I substitute 0, I'll get denominator 9. 5 is a constant over here. 9, I'm not getting 0, hence this will be the part of solution. So you can write e power 0x also, it doesn't matter, anyways it is 1 only, so leave it. Now the thing is that here we got the first part, second part and third part. So this will be yp. Now this final solution will be what? Final solution will be y is equal to yc plus yp. So yc is this part, so write this part first, plus add with this whole part. You can just simplify this 2 3s are like this, you can simplify and write it.